Hello and welcome back to Leilani Electronics. Before we get into this next circuit, like and subscribe to the channel. Check out some more awesome videos. Drop me a line. Tell me what you think. You can print these schematics out over at LeilaniElectronics.com. That's www.LeilaniElectronics.com. Okay, we got two circuits here. The one at the bottom, I just call it it looks like a little Knight Rider circuit. Just some scrolling LEDs. Uses how many LEDs? 16 scrolling LEDs. The jumbo 10mm ones. I'll start using those more. The one at the top is just basically a 2-digit counter, red green. The circuit uses two CDS cells. The CDS cells, they're also called photoresistors, light dependent resistors, or LDRs, or photocells. What is, they change their resistance depending on how much light it detects. So if they detect a lot of light, their resistance goes down. If they're dark, which is no light on them, their resistance increases. So I have a 555 clock pulse generator, and all I did was substitute the timing resistor for these two guys. So that's how I get, a light controlled scrolling LEDs, or with the Knight Rider effect. So it's pretty slick, because depending on how much light it detects, the faster or slower it'll go. Same with the circuit at the top. So we'll do this one at the bottom first. Okay, so right now I have my test light shined on the circuit, just for us to see it. And I also have a flashlight here. So right now it's going about medium. It's counting. So what I'm gonna do is turn off my test light. Okay, my test light's off, and you see how it slowed down. Now I got my handy flashlight here. Now what I'll do is I'll gradually shine light on them, on those two photocells, and you'll see it start to speed up. So I'm just gradually move it over there. Okay, you see it's starting to get faster. And I'll back it away, and it'll go slow. So I'll just hover. I'll just put my fingers over these two. Now it's going really slow, because it's not detecting any light. So I'll move my thumb. Now when I put the flashlight directly over them, it's going to get super fast. See that? There you go. Yeah, I did this circuit a while back, a little over 15 years ago. I tested out on my old Radio Shack board. They don't even make these anymore. Can't believe I still got this, but I have it. Okay, the circuit at the top is just it's just a counter. It'll count from 0 to 99. And that'll also speed up, because what I did, they're both separate circuits. What I did was just take the clock pulse from the 555 over to this circuit. So both schematics are separate. You can build them separate. You don't have to build them together. I just use the same, for this example, just use the same pulse for both circuits. Okay. Okay. Now this circuit at the top uses red, green, 7-segment displays. The first circuit I built, it just was red, so I figured I'd just mix it up, and toss in a dual colored display, just to be different. So it'll count every time it goes to 99. It'll toggle. See, right now it's green. I'll put some light on there. See it with the red. Just to mix it up. Have a different type of circuit. You don't have to have it all red or green, but I thought it'd be nice just to toggle between the two colors. Okay, so I'll hover some light over there, put the flashlight over there, and see how fast it's starting to count. And I back it away. it slows down. That's fast. That's pretty much it. On the website, I just named these circuits CDS 0 to 99 counter and CDS Night Rider counter. So when you go to the website, they'll be up there. You can print them out. We'll give me 1 second. We'll go over the schematic. They're pretty simple. Okay. Okay, so here we got the schematic for the I call it the Night Rider circuit. CDS Night Rider. So when you go to the website, I just labeled it that. Okay, we got our power supply, 7805, 5-volt output, bypass capacitors. We'll scroll up to the top. Okay, here's your 555 clock pulse generator. And there are your CDS cell. I have 2. You can have 2, 3, 4. The more you add, the more resistance you get. This adjusts, you really don't need it. I just left it there in case you want to fine tune the speed or how fast they scroll back and forth. Okay, this goes into 7491, which is a 16-bit up-down counter, over to a 74154, which has 16 outputs. And this is your JK flip-flop. Okay, so as this counts from 0 to 15, once it gets to the 15th output, right here, L15, it'll toggle the clock. Now your Q and your not Q will flop. Your up down. When your up is high, when your when pin 5 is your up down count. When it sees a high, it counts up. When it sees a low, it counts down. So this Q and not Q will toggle. So when this is high, once it gets a clock pulse, it'll go low. Now it'll go the other direction. So now when it comes back up to the last LED, or actually the first LED, it sends it another clock pulse in there, says, hey, now I got to go back the other way. It'll toggle the Q and the not Q. Now it'll start counting back, and it'll just keep doing that. That's how you get your back and forth scrolling. And that's pretty much it for that circuit. Now we'll go over to the 0 to 99 counter. Same concept. The 555 clock pulse generator goes into a 7490, 7447 over to your display. And it's the same scenario. But this one's kind of different. I have it set up so when it gets to 99, your binary 1 and 8, when they both go high, it puts a high on this AND gate. Same with this one. 1 and 8 go high, that means it's 9. 9, 9, they both go high, toggles this clock. And then the Q and not Q flip. And they go over to 2 transistors. Those transistors, when they go off and on, they turn on these Q3 and 4, which are your MOSFET, your MOSFET, your P channels. So when this one goes high, it puts a low on this gate, which turns on the green. This one is low, so it's always pulled up high, so it's off, and vice versa. Then when the count passes 99, it starts all over again, and it's going to keep toggling the clock, and it's going to keep flopping them. Every 99, 0 to 99, it's going to change the color. There's your flip-flop, power supply, bypass capacitors. That's pretty much it. So go to the website, print them out. Hope you like them. It's a fun circuit to work with. And drop me a line, tell me what you think. Thank you.